On the left here, we have a 45, 45, 90 special right triangle, which gets its name because of the 45, 45, and 90-degree angles. And on the right, we have a 30, 60, 90-degree special right triangle, which again gets its name because of its angle measures. Anytime we see either of these special right triangles, we see any triangle that has two 45-degree angles and a 90-degree angle, the side lengths and the hypotenuse are always going to have the same ratio. So in this video, we are going to determine the missing side lengths of each of these triangles when the hypotenuse is equal to 1. So let's start with our 45, 45, and 90-degree triangle. If our two legs of our triangle are equal to A, the hypotenuse is going to be equal to A times the square root of 2. Now this is true for any 45, 45, 90-degree triangle. So if we know that our hypotenuse is equal to 1, we know that's going to be equal to the length of each leg multiplied by the square root of 2. So 1 is equal to A times the square root of 2. Now we can just solve for A now to figure out the length of the two legs. So when we divide both sides of our triangle by the square root of 2, we get A is equal to 1 divided by the square root of 2. We've isolated A, but we want to make sure we have our fraction here in the correct form. We cannot have a radical in our denominator, so to get rid of the radical in our denominator, we are going to multiply both the numerator and the denominator of this fraction by the square root of 2. We're multiplying the numerator and the denominator by the same value, so it will not change the value of our fraction. But when we do that, we're going to get 1 times the square root of 2, or the square root of 2 in our numerator. And in our denominator, we're going to have the square root of 2 times the square root of 2, which is equal to 2. We have now solved for A, so we know that when the hypotenuse of a 45, 45, 90-degree triangle is equal to 1, the two legs are going to be equal to the square root of 2 over 2. And so we're done with our 45, 45, 90-degree triangle. Now let's do the same thing for our 30, 60, 90-degree triangle. And again, we're going to have the same ratio of side lengths for every triangle that has these three angle measures of 30, 60, and 90 degrees. So if we know that our hypotenuse is equal to 1, we know that 1 must be equal to 2a. 1 must be equal to 2a, a being the length of our shorter leg here. So we know that if our hypotenuse is equal to 1, that's going to be double our shorter leg length. So if we divide both sides of our equation here by 2, we get a is equal to 1/2. So we have solved for our shorter leg here. We know that the longer leg of this triangle is going to be equal to a times the square root of 3. A times the square root of 3. And now that we know a, all we have to do is multiply a, or 1/2, times the square root of 3, and that's going to give us the square root of 3 over 2. So we know that this side length here is going to be equal to the square root of 3 over 2. So we have now identified our three side lengths for our 30, 60, 90 triangle when the hypotenuse is equal to 1.